What's up? I'm Vin, and today we're going through the part 2, 3, and 4 questions from the January 2024 Algebra 1 Regents, and I'll leave a link to a copy of these questions in the description below. So first up here, we have the part 2 questions, and every question here is worth 2 credits. Question 25, we have student scores on a recent test are shown in this table over here, and then on the number line, we want to create a dot plot to model the data. So all we have to do here is we have to take all of these numbers and just put a dot over each of the numbers here where they appear. So we have 85, we could just put a dot like this, and then we're going to do this for 96, and we're going to do this for the other values here. And anytime something repeats, we're just going to put another dot above this same dot. So now that we have all these values recorded here in the dot plot, the next thing we want to find is the median test score for the data set. So notice here that we have 1, 2, 3, 4, 5 entries in each row, and there are 4 rows. So that's 20 test scores that we have to keep track of. And when you want to find the median, you want to find the middle test score. And you have to go in order from least to greatest. So here, if I have 20 in total, I'm going to count up to 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So notice that the 10th entry here is going to be at 88. Okay, so I'll just number this on our number line here. This is 88. And then notice that the 11th score is going to be one of the 90s here. Okay, so when we're trying to find the median and you have an even amount of scores or an even amount of entries, the median is the average of the two. So what we're going to do here is, at least what I'm imagining, is because we have 20 total and 20 is even, we're not going to have a true middle. So we have 88 repeating, and then we have 90 like this. So when we have a situation like this, when we're between these two numbers, we have to take the average of those two numbers. So to find the median test score, we're going to take the average of 88 and 90. And with this, you could just eyeball it and just say, what's the middle number? The middle number between 88 and 90 is going to be 89. Or I could just add these two numbers and divide by 2, and our median test score is going to be 89. Question 26, we want to state whether this sum is rational or irrational, and we have to explain our answer. Now, one thing we could do here is just type this in. We have 2 times the square root of 3. So we have 2, and we press second x squared to get our square root. And we have square root of 3, and then plus 6. And notice that we get this number here. So looking at this number, we could see that we have an irrational number because we have an infinite decimal with no pattern to it. And another way to see it is that we're taking the square root of a non-perfect square. So 3 is not a perfect square. And anytime you take the square root of a non-perfect square, you're going to have an irrational number. And if we multiply an irrational number by something like 2, it's still going to be irrational. And something like 6 is rational. When you add a rational and an irrational, you get something irrational. Okay, so these are maybe a lot of properties to remember, but that's why using the calculator can just show you whether your sum is going to be rational or irrational. So first, we're going to say that our sum is irrational. So we're going to state this first, and then we have to explain. We're going to say irrational. And the reason being is that the sum of an irrational number like this plus a rational number like this is irrational. Question 27, we have this table showing data from a recent car trip for the Burke family. And we have to state the average rate of change for the distance traveled between hours 2 and 4, and we have to include appropriate units. So for this question, I'm automatically thinking of the average rate of change formula for some function f of x, and that would be f of b minus f of a over b minus a, okay? And this is when we want to find the average rate of change. So this is for the average rate of change of some function, so of f of x, and it's on the interval ab, okay? So on some closed interval ab. So here they're telling us between hours 2 and 4. Notice the hours row is the top row for the x, and then the bottom row for miles from home is y. Okay, so between hours 2 and 4, we're going to be focusing in on the hours row between 2 and 4. So we're finding the slope between these 2 points here. So I'm just imagining here that we have the points 2, 112, and the other point is 4, 238. Okay, so we're finding the slope between these 2 points. So just know this formula here is basically the slope formula, but it's in function notation. But in this case, they gave us xy notation. So now I'm just going to do that. I'm going to find the slope between these 2 points. I'm going to find the difference in the y values. So you could just think of this as, let's say, x1, y1, and x2, y2. And we're just applying the slope formula. So we have the average rate of change between these 2 hours. We're going to have 238 minus 112 over, and then we have 4 minus 2. And just to make sure that you're using the correct units, notice that the difference in the y values, the units are in the actual table, and that's miles from home. So I'm just going to say miles like this. Okay, so miles, and then the difference between these values, 4 and 2, the units are hours. So our units for our average rate of change is going to be miles per hour. And now all we have to do is just simplify this. So we could just type this in. Let's press alpha y equals enter to pull up a blank fraction. And we have 238 minus 112. And we're dividing by 4 minus 2. And we'll pretend we don't know 4 minus 2 is 2. And we're going to get 63. So our final answer here is going to be 63. And then our units are miles per hour. Okay, so we have miles per hour. And this is going to be our answer to question 27. Question 28, the first thing we want to do is graph this equation on the set of axes below. So we have a linear equation here, and what I like to do for questions like this is get it in the form of y equals mx plus b. Okay, so we could solve this equation for y. So we could start by doing minus 2x on both sides. So we have minus 2x, and then what we're going to have after this is we have 3y equals negative 2x plus 15. And then we're going to divide everything by 3. So we divide this by 3, the negative 2x by 3, and then 15 by 3. And this gives us our equation in slope-intercept form. So we have y equals, and we're going to have negative 2/3 x, and then plus 5. Okay, and the reason why I like to do this is because m is our slope. That tells us our rise over run, and b is our y-intercept. It tells us where our line crosses the y-axis, and it tells us where to begin. So here, we're going to cross the y-axis at 5. So I'm going up 1, 2, 3, 4, 5. Okay, and then the next big idea is that slope. I just like to think of the slope as the rise over the run. Okay, so once I know the slope of my line, and my slope is in fraction form, the numerator tells me how much to rise, and the denominator tells me how much to run. So our slope here, if we look, we have a slope of negative 2/3. Okay, we already took care of the y-intercept. The y-intercept was 5, but our slope is negative 2/3. So we're going to go down 2, and we're going to go over 3. Okay, we're going to rise negative 2 and run 3. So we're going down 1, 2, and over 1, 2, 3. And we could just do this a bunch of times. And we know that we're doing this right if all of the points that we're drawing in here are starting to form a straight line. You know, let's say I mess up and I put a point over here. It's very obvious that that point is at a place because it's not forming a straight line with the other points. So if I want to go backwards, instead of going down 2 to the right 3, I'm going to go up 2 to the left 3 like this. Okay, and I do it once more, and that's going to give us enough points for our line. So now I'm just going to connect all of these. So we just draw in this line like this, and I'll put an arrow at the end of, well, at both ends of the line like this. So here is our graph of this equation. Now, one thing I like to do just to be safe is I'm going to label this graph. So this is the graph of 3y plus 2x is equal to 15. So I'm just copying down the original equation. And now the last thing that we have to answer is, well, we have to explain why negative 6,9 is a solution to the equation. So if we look here, if negative 6,9 is a solution to the equation, we could just find it on the graph and show that that point is lying on the graph of this equation here. So let's count negative 6,9. So we're going to the left 1, 2, 3, 4, 5, 6 to the left. So here's negative 6, and we're going up 9. So up 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice that it puts us right on this point over here. Okay, so what I'm noticing here is that the point negative 6,9 is actually on our line. So we could say that this is a solution to the equation because it lies on the graph of the equation. Question 29, we have to use the quadratic formula to solve this quadratic equation for all values of x, and we're going to round all of our answers to the nearest hundredth. So for this question, if you forget the quadratic formula, it's on the back page of this test, on the reference page. And the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac and all over 2a. Right? So for this question here, I'm noticing that our quadratic equation is in the form of ax squared plus bx plus c equals 0, because in order to use the quadratic formula, we have to make sure that the quadratic is in this form here, and we have 0 on the other side, which is exactly what we have here. So if we identify the a, b, and c value, our a value is the coefficient of x squared, and that's 3. And then our b value is negative 2. Okay, make sure that you include the sign of the number when you're writing down your coefficients here. And then last, our constant c is equal to negative 6. So we could just go ahead now and plug in. We're going to have x equals negative b, so I have negative 2. And then I have plus or minus the square root of, and my b term here is negative 2, and I have to square it. And then I have minus 4 times a times c. And then all of this is being divided by 2 times a. So I have 2 times 3. Now, one thing I want to point out, when you're typing in the discriminant or the term under the square root, you have to make sure that when you're typing in negatives and squaring them, that you put parentheses around them. Because let's say I do negative 2 squared, and I do it this way without parentheses. I'm going to get a different answer, and that's because this is being read as negative 1 times 2 squared. So that's why it's coming out negative like this. Okay, so just make sure that you're putting parentheses. So you have something like negative 2 squared under the square root minus 4 times 3 times negative 6. Okay, so you could just type this in all in one piece. And under the square root, we're going to have a 76. So if I had to simplify this, negative 2 is positive 2. But otherwise, I could just do alpha y equals enter, and I could type this in as is. I could do negative 2, and then I have plus or minus. First, I'll do plus, and then I have exactly what we typed above. So I'll just rewrite that one more time. We have negative 2 squared, and then we have minus 4 times 3 times negative 6. Okay, now I could exit the square root and go to the denominator, and we have 2 times 3. So we have 2 times 3, and then I press enter. But I also have to consider the minus. So I'm going to go up to this and press enter. And now all I have to do is scroll to the left until I get to the plus sign. And I hover over it and press minus. And I press enter one more time, and I get all of the answers I need. So if I want to show a nice in-between step here, I could say x equals negative 2 is positive 2. And then I have plus or minus the square root of. And when we simplified this stuff under the square root, we got 76. Okay, and then this is all over 6. So now if I want to write out all of the answers and we're rounding to the nearest hundredth, what I'm going to do is first I'll write out the x equals, and we have 2 plus the square root of 76 over 6. Okay, and for this one, the plus solution worked out to this decimal value here. So I'm rounding to the nearest hundredth. So I look out to the hundredth place, and to the right is a 6, which is bigger than 5. So I'm rounding up to 1.79. So this I could just say is equal to 1.79. So here's one answer, and then the second answer, we're going to have 2 minus the square root of 76, all divided by 6. And if I round this answer to the nearest hundredth, I look to the hundredths place is a 1, to the right is a 9, so I'm rounding this one to negative 1.12. Okay, so here are our two answers. Question 30, we have this piecewise function f of x, and we want to state the value of f of 3, and we have to justify our answer. So when you're evaluating a piecewise function, what you want to think about first is whether or not the number that you're plugging in belongs where it belongs. Okay, so what I mean by that is if I'm plugging in 3, the first thing I'm asking myself is, does 3 fit in the top row or the bottom row? So is 3 greater than 3, or is 3 less than or equal to 3? Okay, so that's the first thing that we have to be able to answer. So since 3 is less than or equal to 3, this is a true statement. This tells us that we're going to plug into the bottom row. Okay, so we plug into the bottom. Okay, so that's the first thing you have to do, is that the number you're plugging in, you have to see where it belongs. So since we have to justify our answer, I would just casually mention here that 3 is less than or equal to 3. So f of 3 is equal to, and now we could plug in, but once again, we're plugging into the bottom here. So we're going to plug in, we have negative, and then we have 3 squared, and then plus 15. Now, remember what I said before with the quadratic equation question, that when you're plugging in, you have to be careful with parentheses. But notice this time around that we're not plugging into x squared, we're plugging into negative x squared. So just think of this as negative x squared is negative 1 times x squared. Okay, so when I plug in like this, I'm just leaving that negative on the outside, and then I'm doing 3 squared. So this is going to work out to, we're going to have f of 3 equals 3 squared is 9, but with a minus in front is negative 9. And negative 9 plus 15 is going to be equal to, we have positive 6. Okay, so here's our function value. Now, if you're nervous plugging into this by hand without the calculator, just go to the y equals and write negative x squared plus 15. And we only have to worry about what's going on at x equals 3. So I could just press second graph and go to the table and notice that when x equals 3, we have y is equal to 6. So this tells us that our evaluation here, plugging in 3 to the function, worked out nicely. So 6 is our answer. Question 31, we have this quadratic equation here, and we want to write it in the form of x minus p squared equals q. So for this question, we have to know how to complete the square. And the idea behind completing the square is you want to get the quadratic in the form of x squared plus or minus some number b times x, and then equals some other constant. Okay, so I'll just call the constant on the other side k. So this just represents some constant. And the technique involved with completing the square is you want to find half of the b term and you want to square it. Okay, and then that's the number that you're going to add to both sides. So we target the coefficient of x. But once again, you need to have this in the form of x squared plus bx. And that's what we have right here. So what I'm thinking here is I'm doing half of negative 8, and then I'm squaring it. And that's what I want to add to both sides. So I would have negative 4 squared, which is equal to 16. So that's the mystery value that we're going to add to both sides of this equation. So I have x squared minus 8x, and I'll leave a space, equals negative 41. And once again, I'm going to add 16 to both sides. And the reason this is called completing the square is because if you add the right number to both sides, the quadratic that you have on the left, this is a perfect square trinomial. Okay, when I look for two numbers that have a sum of negative 8 and the numbers also have to have a product of positive 16, I'm going to have a perfect square trinomial on the left. And that means that we're going to have matching factors, okay? Because if you think about it, a perfect square, like think of, let's say 16 is equal to 4 times 4, and those are matching factors. So the left side, notice we have matching factors, x minus 4 times x minus 4. And we could verify negative 4 plus negative 4 is negative 8, and then the product of negative 4 and negative 4 is positive 16. And now on the right side, negative 41 plus 16 is negative 25. But we want to write this in the form of x minus some number squared equals some other number. So x minus 4 times x minus 4 is x minus 4 squared. And then we have this is equal to negative 25. And they didn't tell us to solve for x. They just told us to get this quadratic in this form here. So this is our answer to 31. Question 32, we want to factor this completely. And the first thing that's jumping out at me is that we have a greatest common factor of 4. And when I want to write my leftovers inside the parentheses, I'm dividing each thing by 4. Okay, so that's one of the things that I'm thinking of. 36 divided by 4 is 9. And if I do negative 4x squared over 4, I would just have minus x squared left like this. And I know that I did this right because if I distribute my answer, if I do 4 times 9, I get 36. And if I do 4 times minus x squared, I get this. Now, the most common mistake here is that people just stop at this step. But this question is telling you to factor completely, okay? So when you hear factor completely, that means just keep going. You probably have more than one step. But factor completely means to factor until you can't factor the expression anymore, okay? So then the next thing I'm noticing here, 9 minus x squared is in the form of a squared minus b squared. And this is a difference of two squares. And this factors very nicely to a plus b times a minus b. So when I look at this expression over here, I'm imagining that as 3 squared minus x squared, okay? And then this I could express as 3 plus x times 3 minus x. All right, so that's the math that I'm doing in my head. Now, one thing that students mess up also is that they prefer this to say x squared minus 9. So they say, oh, I could just switch the order and say x plus 3 times x minus 3. But be careful, that's a very dangerous bear trap, all right? Just make sure if the 9 is first, the square root of 9, which is 3, is going to go first in both of these binomials. If you mix up the order for the plus, like 3 plus x or x plus 3, the order is forgiving because addition is commutative. But with subtraction, the order is very important, okay? So it just helps to write the 3 first since that's the square root of the first term. And now we're going to have plus or minus, and then we could write our x after like this, okay? So here is our expression factored completely. So now we're moving on to the part 3s, and every question here is worth 4 credits. Question 33, we have Laura playing golf, and she hits a ball from the ground, and the height in feet of her golf ball can be modeled by the function h of t. And the first thing we have to do is graph h of t on the set of axes below. So let's go over to the y equals, and we'll type in the function h of t. We have negative 16t squared, but we'll go ahead and use x. So we have negative 16x squared, and then we have plus 48x. And we press graph, but notice we can't really see much of what's going on. And that's because the scale of the graph has to match what they gave us. So we can make our y-axis go from 0 to 40, and we'll make our x-axis go from 0 to 4. So we could go to the window over here, and we're going to switch the x minimum to 0 and the x maximum to 4. And then we have the y minimum will switch to 0, and the y maximum will switch to 40. Okay, so now we press graph, and we get a much better idea of what's going on. Now, if we really want to be precise when we graph this, we need a table. So we press second graph to go to the table. And notice these values here. But notice that we have at t equals 1 and t equals 2 that we're at y equals 32. But we can't see what's going on between 1 and 2. So what you want to do is press second window and switch the independent from auto to ask. Now, what this allows you to do is it allows you to make a custom table. So I could type in 0. I could type in stuff like 0.5 and then maybe 1, 2. And if I want to know what's going on between 1 and 2, I could write, let's say 1.5. So this is just a nice feature that allows you to make a custom table. Okay, so I'll just do this all the way until we go back to 0. So we'll count by 0.5 instead. So now let's plot these points and connect them. Now, me personally, I like to include a table of values when I'm making my graph, but this graph here is going to be an accurate representation of h of t. So now next we want to answer what is the maximum height in feet that the golf ball reaches on this hit. So this we just have to identify it, and this is why I'm glad that we took the time here to count by 0.5, because it's very obvious now that the vertex is occurring over here at 1.536. Okay, so this is the maximum height of the ball. So when we want to just answer here, what is the maximum height? This occurs at the vertex. It's going to be 36 feet. Okay, so we're just going to say 36 feet. So we're just recording what we see. We're looking at the y value here. Now, one thing that comes to mind is when I'm looking at a question like this, I could also use the formula for the axis of symmetry, the formula x equals negative b over 2a. And if I use that idea for this question, I could say that at t equals negative, and my b term is 48. So I have negative 48 over 2 times negative 16. That if I work something like this out, well, this is going to simplify. 48 over 16 is 3. And then 3 divided by 2 is 1.5. Okay, I do have a negative here and here, and a negative divided by a negative is a positive. So that's how I know this is working out positive. So I can, once again, just use this formula for finding the axis of symmetry. And that just tells me what my x, or in this case, my t value is at my vertex. Okay, so that's how I know 100% that the vertex is occurring here. Okay, but the maximum height is 36 feet. Now, the last thing that we have to answer is how many seconds does it take the golf ball to hit the ground? Well, if we look at this graph tells a story. At time 0, this is when Laura hits the golf ball. And then the golf ball goes up. And how long does it take for the golf ball to go back to a height of 0? It takes the distance between 0 and 3, so it takes 3 seconds. Okay, so we're just going to say 3 seconds. That's how long it takes for the golf ball to return. None of these questions say to justify or explain, so we just have to use the graph and extract that information to write our answer to the last 2 parts here. So this is going to get us full credit. Question 34, we have this table below showing the number of SAT prep classes 5 students attended and the scores they received on the test. And we have to do a few things here, but the first thing we have to do is state the linear regression equation for this data set. So in a moment, we're going to have to find the correlation coefficient. So I would go over to mode and make sure that the diagnostic is on. So if you see over here, stats diagnostics is off. So I'm going to scroll down like this to stat diagnostics, and I'm going to switch it on. So I'm going to go to the right and press enter, and then I'm going to enter the data. So I'm going to go to stats, edit, and for our L1 column here, we're going to type in the X values. We have 3, and then we have 1. Let's see, we have 6, 7, and then another 6 like this. Okay. And then I'm going to go to the L2 column and write in the corresponding y values. So for the first entry here, we had 3 and then 500. And then afterwards, we had 410. We had 620. And then after this, we had 720. And then 500. Okay, so here are the values all entered. And we are calculating a linear regression. So we're going to go to Stats, Calculate. Linear regression is option 4. So I press 4. And I just keep pressing enter till I get to calculate. And these are all the values that we need. So with these values here, now we could write our linear regression equation. So we have y equals ax plus b, and we're rounding all values to the nearest hundredth. So for the a value here, notice in the hundredth spot, we have a 7, and to the right is a 6. So we're going to round this up to 40.48. So we have 40.48. And be mindful here that the a value is the coefficient or the number in front of the x. So we have 40.48x plus the b value is over here. And once again, we're rounding to the nearest hundredth. So we look at the 0 in the hundredth spot, and to the right is a 9. So we're going to round up to 363.81. Okay, so here is our linear regression equation. For the second part of this question, we just have to state the correlation coefficient, and we're going to round to the nearest hundredth. So I switched the diagnostics to on in the calculator so that it would give us the R value over here. Okay, so that's our correlation coefficient. And to the nearest hundredth, we just look over here at the hundredths place is a 4, and to the right is a 0. So we would round down to 0.84. So here is our correlation coefficient. Now for the last part here, we want to state what this correlation coefficient indicates about the linear fit of the data. Well, one thing we have to know for this part is we have to know what the actual value of the correlation coefficient means. So your correlation coefficients could be between -1 and 1. And if your correlation coefficient is close to 0, this means no correlation. Okay, so no correlation when we are at 0. And I'll just abbreviate. When we are close to -1 or +1, that's going to be a strong correlation. Okay. And the more we move away from -1 or +1 and get closer to 0, the weaker the correlation is. So looking at this, 0.84 is pretty close to 1. Okay, that's closer to 1 than it is to 0. So we would say that this is a strong correlation. And then to be extra precise here, we could just go back to what the units represent in the context of the question. And there is a strong positive correlation between the number of prep classes attended and the student's math SAT score. Now, one thing to point out here is that we're using the word correlation, but just remember, correlation does not imply causation. We cannot safely say that if a student attends X number of prep classes, that they're automatically going to have an amazing SAT score, or at least a math SAT score. Okay, so a correlation just shows the relationship between the two, but there is a strong correlation, a strong positive correlation between the number of prep classes a student attends and their math SAT score. Question 35, Julia is 4 years older than twice Kelly's age X, and the product of their ages is 96. And we need to write an equation that models this situation. So for questions like this, I like to write the names of the people involved and put the algebraic expression that represents their age next to each of them. So Kelly is X, and then I reread this a second time. So Julia, they said, is 4 years older than twice Kelly's age X. So read this a few times. 4 years older than twice Kelly's age X will get you to this part, to 2x plus 4. All right, and I'll make this a little bit neater. So we have 2x and then plus 4. And just if we think about this very carefully, 4 years older, that's why we're doing plus 4. And then twice Kelly's age X means times 2. So this gets us to the setup. And then the $1 million detail here, though, that helps us build the equation is that the product of their ages is 96. So if I multiply x times 2x plus 4, we could set this now equal to 96. Okay, so this would be the equation that models the situation. So now the next thing we're going to do is determine Kelly's age algebraically. So we could take this equation here and we could distribute the x. So we're going to get 2x squared and then plus 4x is equal to 96. Now for this here, we're going to move the 96 to the left side because we have a quadratic equation. So when you're trying to solve a quadratic equation algebraically, you want to move everything to one side so that you could factor or try to factor. We could always use the quadratic formula, but factoring I just find to be a little bit nicer. So we have now on the left side, we have 2x squared plus 4x minus 96 is equal to 0. And for this, I would factor out a greatest common factor of 2. So if I divide everything by 2, now I'm going to have x squared plus 2x and then minus 48. And then next, now we could factor this. We're looking for two numbers that have a sum of positive 2, and the two numbers also have to have a product of negative 48. So here we're going to have 2 times, and the two numbers that work are going to be positive 8 and negative 6. Okay, so once we get to this step, to find the roots of this equation here, I could set each of these factors equal to 0, but setting 2 equals to 0 is kind of a silly statement to make. All right, 2 equals 0 just is meaningless. So I'm not going to waste time here writing that and then rejecting it. I just won't do that. Okay, if I set x plus 8 equal to 0, that's going to give us a root of x equals negative 8, which we are going to reject because we're talking about somebody's age. And if Kelly is x years old, she can't be negative 8 years old. Okay, we can't say like this is 8 years before she was born. That's just, we're going to pretend like, yeah, Kelly's here and this is not like in the past. Okay, so this we're going to reject. However, the second factor, if we look at this one, x minus 6 equals 0, we could solve and we'll get x equals 6. And this will make sense in the context of the question. And remember, Kelly is x years old. If we look back to this part, Kelly is x years old. So that tells us, if we're just going to state Kelly's age, we're going to say that Kelly is 6 years old. Okay, so Kelly is 6 years old. And now for the last part, we want to state the difference between Julia's and Kelly's ages in years. So we have that Kelly is 6 years old. Okay, so Kelly is 6 years old. And now Julia, we could find her age by plugging in x equals 6. Okay, we found x is equal to 6. So now we could do 2 times 6 and then plus 4. And this is going to give us 12 plus 4 is 16. Okay, so Julia is 16 years old. So the difference between Julia's and Kelly's ages in years, we could say that the difference, so I'm just going to write this over here, the difference in their ages is equal to, and we're going to say 16 minus 6, and we're going to say years. Okay, so the difference is in years, and 16 minus 6 is equal to 10. So they are 10 years away from each other. Okay, so this would be their difference. Question 36, first we're going to graph this system of inequalities and then we'll label the solution set S. So what I'm thinking about for a question like this, since we have a system of linear inequalities, is I'm thinking about y equals mx plus b. And this, when we get the inequalities in the form of mx plus b, this is going to help us identify the slope and the y-intercept. Okay, so that's why we're doing this. And I'm looking at the first inequality, the 2x minus y is greater than 4. And the first thing I'll do with this one is I will subtract 2x on both sides. So I want to get the y term by itself. So we're going to do minus 2x on the left and minus 2x on the right. And what we have after this, 2x minus 2x cancels. We have minus y is greater than, we have a negative 2x, and we have a positive 4. And now I'm going to divide everything by negative 1 just to get this to say y on its own. Okay, so then we have y is, and we divided by a negative on both sides. So just know there's a little sneaky detail. When you multiply or divide an inequality by a negative, the sign flips. Okay, so now this is going to say y less than negative 2x over negative 1 is 2x, and then 4 divided by negative 1 is minus 4. So this is our first inequality in the form of mx plus b. So now I'll go over to the graph here, and we're going to start at negative 4. That's our y-intercept. So I'm going down 1, 2, 3, 4, and our slope is positive 2. So this tells us, the slope tells us the rise over the run. So we're going to go up 2 over 1 like this. So this is our slope. We can use a calculator and just type in y equals 2x minus 4 and then copy a table of values down if you would prefer to do it that way. But me personally, I like to use the mx plus b idea to graph, any type of linear equation or inequality. Now, if I want to go backwards, instead of going up 2 over 1, I'm going to go down 2 to the left 1 like this. And then now, once I get this far, what I'm going to do is I'm going to connect these points with a dotted line because this is strictly less than, okay? If this was less than or equal to, I would use a solid line. but it is less than. So we'll connect this with the dotted line. And now we could throw arrows on at the end, and we're going to shade under this line here, okay? So I'm just going to shade everything under like this, and this represents the solution to the first inequality. Now for the second inequality, x plus 3y greater than 6, we're going to solve for y by subtracting x first. So we're going to do minus x on both sides, and now we have x minus x canceling. We have 3y is greater than negative x plus 6, and now I'll just divide everything by 3. Okay, so we're dividing all the terms by 3. And we're dividing by a positive, so we don't have to worry about the sign flipping. And now this I'll write as negative 1/3 times x plus 6 divided by 3 is 2. The reason I'm allowed to do this is there's always an invisible 1 in front of an x if you don't have any number written there. Okay, so that's how I know this part here is fine. So this is what I'm going to graph over here in this section. So I'm starting at y equals 2 on the y-axis. That's our y-intercept. And now I have a negative slope. I have a slope of negative 1/3. So I'm doing the rise over the run. I'm going to go down 1 and to the right 1, 2, 3 like this. Okay, so when I have a negative slope, the line should be dropping like this. So I'm going down 1 and then to the right 1, 2, 3. So I'm just going to repeat this until I cover enough space here like this. Now, if I mess up, let's say that I say, all right, the next point goes here. You could see that these points are no longer forming a straight line. So that's how you know if you messed one of them up, if the straight line is broken. So just don't accept it. Make sure that you see that all your points are forming a straight line. So this is enough here. And what I'm going to do is I'm just going to connect these like this. And I'm going to put an arrow at the end of this dotted line. And this is a y greater than situation. So I'm going to just shade everything like this above. And we just have to be very careful of one thing. Actually, I should say we should be very careful about two things. For one, we have to label the solution set S. So I'm just going to make sure this is like very bold and that it's there, that it stands out. So there's our solution set. But also make sure that you actually label one of the inequalities. Okay, if you want to label both, you can, but I could just point to this one here. I'll just make that a little bit neater, and I could say this came from our second inequality. This was x plus 3y is greater than 6. And if you want to label both of them, that's fine. We could say that this inequality was the 2x minus y is greater than 4 inequality. So now for the last part of this question, is 4,2 a solution to this system? And we have to justify our answer. So for this part, we could just plot the point 4,2. So we go to the right 1, 2, 3, 4, and then we go up 2. And notice that this point here lies in the solution set S. It's in the overlap of both inequalities here. So we could say, for one, that yes, this is a solution. And the justification here is that it lies in the overlap of both inequalities. So now we move on to the part 4 question, the final boss, and this question is worth 6 credits. So for this question, we have Jim, and he has a bag of coins, and the number of nickels N and the number of quarters Q totaled 28 coins, and the combined value of the coins was $4. And we have to write a system of equations that models this situation. So for this question, we have to know that a nickel is worth 5 cents, which is $0.05. So if we multiply 0.05 by N, this will tell us how much money we have in nickels, or how much money Jim has in his bag of coins in nickels. And then next, we're going to add the quarters are worth 25 cents. So that's 0.25. So if we do 0.25 times Q, this will tell us how much money Jim has in quarters. Okay, but they're telling us that the combined value of the coins is $4. So that's 4.00 like this. Okay, so I'm just writing it in money terms like this. But they also tell us that the number of coins in total is 28 coins. So that's the number of nickels plus the number of quarters is equal to 28. Okay, so this is the system of equations that would model this situation. So now we're going to algebraically determine both the number of quarters Q and the number of nickels N that Jim had in the bag. So for this top equation, I'm going to leave this one alone. I'm going to leave it as 0.05 N plus 0.25 times Q equals 4.00. But then for the bottom equation, what I want to do is I want a variable to eliminate. So I want to be strategic here and pick out the easier one to eliminate. And just looking at this, I want to eliminate the variable Q. And the reason being, I'm just doing this because I don't want to move to a calculator, but I could just as easily eliminate the variable n here. But I'm going to multiply the bottom equation by negative 0.25. Okay, so the reason why I'm doing this is I want the coefficient of q to be the matching opposite of this one so that they can cancel out. Okay, so I'll just make a little space here. And what we're going to do next is we're just going to write the new system after we do this multiplication here. So this is going to send us, and we'll make this neater, this is going to send us to 0.05n plus 0.25q equals 4. And the bottom equation, let's just think about this. We're going to have negative 0.25 times n, and then we're going to have minus 0.25 times q. And then for this part, we're doing negative 0.25 times 28, which is negative 7. Okay, and I'm just going to write this a little bit neater. We're going to have negative and then 7.00. Now, the math that I'm doing in my head, although, we do get a calculator for this test, is I'm doing 28 divided by negative 4, because negative 0.25 is the same thing as negative 1/4. So the math that I was doing in my head is I did 28 times negative 1/4, which is the same thing as 28 divided by negative 4. So that's where the negative 7 is coming from. So now from here, I add these two together, and I notice over here that these terms are just going to eliminate. Okay, so the 0.25q and the minus 0.25q, when we add, they're matching opposites, so they just cancel out. And now 0.05 minus 0.25, the math that I'm doing in my head here is I'm just doing 5 minus 25 is negative 20. Okay, so that's the math that's going on in my head to get to the next part here. So what I have next is I'm going to have negative 0.20 times n, and this is equal to negative 3.00. And now to solve for n, I'm just going to divide both sides by negative 0.20. And for this part, the math that I'm doing in my head here, I think it's fun to go over some mental math. If you don't want to do the mental math, like, obviously, if it's the actual test, like, for sure, use a calculator just to verify, but this is just fun for practice. So negative 0.20 is the same thing as negative 1/5. So when I divide by negative 1/5, that's the same thing as multiplying by negative 5. Okay, so I'm really just multiplying this top value here by 5, which is going to give us just n like this. But if I multiply this top value by negative 5, negative 3 times negative 5 is 15. Okay, so this tells us that there are 15 nickels in Jim's bag. But now let's think about, we want to also solve for the number of quarters. And I'm going to go back to this equation over here. Okay, this is the nicest equation that we have. So now that we have the number of nickels, to find the number of quarters, we could say 15 plus q is equal to 28. And now to solve for q, just do minus 15 on both sides. Okay, and this is going to give us, we're going to have q equals 13. All right, so Jim has 13 quarters in the bag and has 15 nickels in the bag. Now, one thing I want to point out, let's say the algebra is a little intimidating, but you want to get partial credit for this question. You could go over to the apps button here, and option 9 is polynomial simultaneous. And I'm going to go to simultaneous equation solver number 2. And what I could do here is I could solve the system in the calculator, explain what I did in the calculator, and I'll get partial credit. Okay, that's better than getting a 0. If a student, if you're at the test and you're like, oh no, this system seems really tough, you could always use the calculator and just say, hey, I did this in the calculator, and you'll get half of the credit that you would get if you did it algebraically. All right, or if you just want to do this in the calculator just to see how your answer compares. But I have two equations here, and I have two variables that I don't know. I don't know n, and I don't know q. So now I'm going to press graph to go next. And I'm going to pretend that n is x and q is y. So I have 0.05 times x, and then I'm going to press enter to move past the plus, and then we have 0.25 times y, and this is equal to just 4. And then in the next line, we have 1x plus 1y equals 28. Okay, so I'm just entering everything in. And now to solve, I press graph. And notice that it gives us that n is equal to 15. See, it gives us exactly what we had over here. N is equal to 15, and y is equal to 13. Okay, so our work checks out. So now for the last part of this question, we have Jim was given an additional $3, which was made up of equal numbers of nickels and quarters. And we want to know how many of each coin was he given, and we have to justify our answer. Well, let's say that he was given X nickels and X quarters, okay? Because we were told that he was given equal numbers of nickels and quarters. Well, the nickels are worth 5 cents, so we have 0.05 times X, and then plus the amount of money he was given in quarters, we could say is 0.25 times X. And once again, we're using X twice because of this detail here. They said that he was given, or he has, equal numbers of nickels and quarters. So now we could set this equal to $3, okay? So equal to 3.00. And now from this part here, we're going to just add these two. We're going to combine like terms. And just imagine you're doing 25 plus 5 is 30, but there's a 0 point at the beginning. So we have 0.30x is equal to, and then we have 3.00. And now we just divide here. We have divide by 0.30 on the left and right side. And now on the left side, things are going to cancel like this. And now we're going to have x equals, and we want to know how many times does 0.30 go into 3. We could just use a calculator, but this is going to go in 10 times. All right. The math that I'm doing in my head, just so you could work this out. This is just a nice little exercise. Is I'm just imagining here I have 3 divided by 0.3. So now I'll get rid of that like extra stuff. If I multiply the top and bottom by 10 first, this would give me 30 divided by 3. Okay, so 3 times 10 is 30, and 0.3 times 10, the decimal moves 1 to the right and gives us 3. And 30 divided by 3 is definitely 10. Okay, so how many of each coin was he given? We would say 10 of each coin. Okay, so Jim was given 10 of each coin, and this would be our answer to the last part of this question.